Hello, this is Edge from Scildburg, and today we're going to see how to use a logic gate IC. This is an OR gate IC, integrated circuit, and we're just going to go over really quickly how to use one. First of all, each one of these pins has a function. This pin here is the ground input for the logic IC. And the way these pins work is, if you see this little notch here, sometimes there's a little dot on the left corner. This one happens to have a notch on the end of it. But that would be the top, and you start counting down 1, 2, 3, 4, 5, 6, 7. And then you start on the next side and you start at the bottom. 8, 9, 10, 11, 12, 13, 14. So for this particular IC right here, pin number 7 is ground, and pin number 14 is your positive input. So ground 7, positive 14. And if you look at this data sheet, which I'll show you here, you can see which pins are actually showing the inputs and outputs of the logic gate. There's 4 logic gates on this particular IC, but we're only going to use the first one. So for this gate, we have pins 1 and 2 as inputs and pin 3 as the output. So what we're going to do here is we have 2 buttons, 2 little push buttons. Each one is going from positive to the button, positive to the button. So we're going to take these buttons. These buttons, for some reason, connect from the opposite corner. You may have different buttons, but that's the way these work. So we're just going to attach the buttons to where they'll be closed. The circuit will be closed if we push the button. So we're just going to bring this button to the first input, like so. We're going to bring this button to the second input, which is pin number 2, like that. And here you see we have 2 resistors. These are both 10K ohm resistors. What these are doing is, these are going from each of the inputs to ground. What that will do is, if there's any, unless the button is pressed, any electricity that's going into the input will be pulled down. That's what it's called, a pull down resistor. Any electricity that's going into the input will be pulled down into ground, so it won't reach the button. And that's what, or the input. So that's what it's for. So we have our pull down resistors, which is good. So now when we push the button, the electricity will go into each input. If we're not pushing the button, the electricity that might be going into there will be pulled down to ground. So the only thing else we're going to do is we're going to take our LED, and since we're going to have a positive signal coming out of our output, which is pin 3, we are just going to put our LED on pin 3 on the positive side. Negative side will have an empty slot, and we're just going to have our resistor going to ground to the negative side of the LED, and that's it. Now we'll add power to it. As you can see, it's not on. But if we push either of the buttons or both of the buttons, the LED will come on. Just like so. Push both of the buttons, it comes on. And the reason that is the logic for an OR gate is, if none of the buttons are pressed, or if none of the inputs have power, then there's nothing coming out of the output. If either of the buttons is pressed, then it's going to be, the output will be high or a 1 in logic. Right now it's 0. Now it's 1. Now it's 1. Now it's 1. So if you have 0, 0, you'll have 0 here. If you have 1, 0, you'll have 1 here. If you have 0, 1, you'll have 1 here. And if you have 1, 1, you'll have 1 here. And that is an OR logic gate IC. Very simple to use. If you want it most of the time, any other time, if you're using this in a project, you want to take any inputs that you aren't using and move them to ground. I'm not doing that now because this is just to show you. But normally, any unused inputs, we will ground them out. So you just have a wire going from the input to ground on any of them that aren't used. And that's it. That is a logic IC. Thanks for watching.